Okay, so we have our final piece, hopefully, about the mechanics of breathing. Pulmonary ventilation consists of two phases. So inspiration is when you breathe in, and so the gas flows into the lungs, and expiration is when the gases exit the lungs and they flow out. Oops, sorry. We're gonna move this up a little bit. We're having this issue again. Aha. So the muscles that are located between the ribs, you need to know, is the inspiratory intercostals, so you have the intercostal muscles, and also the expiratory intercostals as well. But the biggest one that we're going to talk about is that diaphragm. Okay. So these are also known as the internal and external intercostal muscles. Okay. So the gas actually diffuses down its individual pressure gradient. So you have the external exchange, or the external respiration, which is between the lungs and alveoli and capillary blood. So the oxygen leaves the alveoli and enters the capillaries, of course, and then the carbon dioxide swaps places with it and leaves the capillaries and enters the alveoli. So at the end of the inhale, the gases change places, and this is why when you inhale, the oxygen goes in, and when you exhale, there's carbon dioxide coming out. Once the oxygen reaches the capillaries, what happens is that it goes through internal gas exchange or internal respiration, where the hemoglobin takes the oxygen, goes all the way down into the blood streams, and it goes back to the heart and back out through the aorta and all the different capillaries and whatnot. Then what'll happen is that it'll go to the local tissues where the byproduct, the cells, would have created or produced as a byproduct carbon dioxide. It's just a cost of doing business. What happens is that you break down the carbon compounds, which is like a sugar, for instance, then they will generate carbon dioxide as a byproduct. So what ends up happening is that there's more carbon dioxide in the cells as the hemoglobin is going by, and then there's more oxygen on the hemoglobin, and so by diffusion they independently go down their separate gradients. Therefore, the oxygen that's on the hemoglobin comes into the cell, the carbon dioxide that was in the cell goes out of the cell. And that's the internal gas exchange or respiration. If there is a gas exchange that occurs inside the cell, which it does, there's oxygen that moves within the cell for the purposes of making energy. So that is actually then called cellular respiration. I know you guys super love my drawings, so I'm gonna give you one. So when you look here, you've got, let's make sure we get that right. Okay, you remember that's the it looks even funnier on tape. So you've got your alveolus, you've got the capillary that's wrapping around it. Then at some point it's going to go out, and it's going to, this is a cell, by the way, with the nucleus, yay. It's going to go out, and it's going to do the same thing. There's the capillary there, cell there. So on inspiration, the oxygen is going to come in this way. And then the blood that arrives to the lungs is going to be high in CO2. So what's going to happen is on the top of the inhale, there's the first switch. The carbon dioxide that was in the capillaries goes into the alveoli, and the oxygen that was in the alveoli go into the capillary. This is the point of oxygenation on the pulmonary circuit. Now, once that happens, top of the inhale, swap, top of the exhale, these switch places, carbon dioxide leaves. Okay, then the newly oxygenated blood goes down, and now there's a whole bunch of oxygen here in this capillary, and the byproduct of cellular respiration is CO2. So then This is the second point of gas exchange, where it becomes deoxygenated. Now, so from here to here is external, because this area, right, is all contiguous with the outside world, meaning if we went all the way out, it would eventually exit the system. And so that is between the outside and the inside, so it's called external respiration. Now, in this case, both parts are inside. So how I remember it is that this gas exchange is called internal respiration, because now the gas exchange is happening within two compartments on the inside of the body. Now, the third level is when the cell is actually, there's gas exchange happening within the cell itself, and that is called, that's not a very neat, it's called cellular respiration. Okay, so there's that. Now, moving forward, let's move on. Okay, gases diffuse down the pressure gradients. We talked about it. Partial pressure, P, is the pressure from an individual's gas in a mixture of gases. Each gas in a mixture diffuses independently of the other gases in a mixture. So it doesn't matter how much gas and what other gases are in there, it will move independently and assort independently. And the greater difference in the partial pressures of a gas, the faster the rate of diffusion. What I mean by that is, let's see. Oh, So, okay. So, that gradient is a lot bigger than, per se, that gradient. So the movement of the little circles here is going to be much larger than, let's say, here. Because the difference, which is the gradient, which creates the gradient, the difference between the concentration on this side and that side are indeed a lot bigger in difference than this one. Okay. Let's keep moving forward. This picture is actually kind of cool. I'm going to see if I can make it bigger for you. Let's see if I can make this picture bigger for you. Oh, that didn't work out so well. Okay, so this is just another depiction of the internal, external, and cellular respiratory processes. It's not as cool as a picture that I just drew for you, but hey, it's all good. Next. So, couple things. Please know the learning objectives, process of internal and external gas exchange or respiration, and list the ways that oxygen and carbon dioxide are transported through the blood. Then we just got through talking about that. Let's keep going. Okay, gases diffuse down the gradient, partial pressure, talked about those. Okay. So with gas exchange there, you can see all of these different ways this is getting, described to you. If you like one specific way of doing it, be my guest. Oh, phone's ringing. Okay. In the interstitial fluid, the partial pressure, this is going to be example questions. and I will let you test your knowledge on this. Okay. Transport of oxygen. Most oxygen, 98.5%, is transported in the blood by hemoglobin. Transport of carbon dioxide, 10% is dissolved in the plasma. 15% is combined with proteins of hemoglobin and plasma proteins, and 75% dissolves in the blood fluids and is converted to bicarbonate ions. Bicarbonate ions are especially important because it actually helps in acid-base balance. And bicarbonate is actually which helps keep you more alkaline, which is important because your blood is actually kept slightly more alkaline. This, although it's very intriguing, I will not be testing you on that. We can skip 81 and 82. Couple things you should know though. Decreased respiration causes you to have, oh, I don't like that.